let's take a look at some of the most creative robots we've seen in the FTC DECODE season so far. And then the whole system moves back to be able to launch it up into that flywheel. I'm Coach Pratt, and I've been teaching robotics design for over a decade now, and I've mentored FTC teams winning national championships and multiple Inspire Awards. And today we're going to take a look at some small wins that your team can do on your robot design that aren't dramatic shifts, but are likely ways that you can improve your robot's performance as we move towards the Premiers and World Championship stage. And at the end, we'll take a look at one of the coolest designs I've seen for a robot all season. So first up, let's talk about the concept of shooting on the move. And we've talked about this before, but I want to get a little deeper into this because there are some teams now that are starting to do some things that I haven't seen any teams get up to yet. So first up, we've got Team Iron Lions here. And they've got a shoot on the move algorithm, just so you're aware of what shooting on the move is. It is, of course, as the name implies, you're capable of moving and shooting on the move. And I think this is a really great example of it. Now, keep in mind that presently this shoot on the move obviously is not inside of that triangle where they're allowed to be. But when you're doing your tuning and your testing, there's no reason why you have to tune and test it only inside that triangle. It also shows that they've got some strong linear interpolation Y table lookups, which basically means that depending on where they are on the field, they're able to automatically change the angle of their hood or modulate the RPM on the flywheel to be able to make sure that they make it into that goal. And one of the teams that I've seen that I haven't seen yet is Team 33680 Atomix Hearts. And I want you to take a look at the start of their autonomous because they have a shoot on the move during their autonomous, which actually I haven't yet seen some teams performing at the beginning of their autonomous. So they're capable of moving up and then shooting as well. I think that some of their braking is a little bit aggressive. We'll see here, they do quite a bit of pop-up, and they're also coming over that center line, so they've really got to be cautious there. That being said, it is quite impressive to be able to have in the autonomous section to be able to have a shoot while moving. Now, in terms of ways they might be able to improve some of this as well, they could get themselves a little bit tighter on that white line, and they could even potentially start firing up that flywheel before they get to that white line to be able to get further in. Now, some of this is starting to get into some of that hyper-optimization area, but if you really want to perform at your premier events and at your world championships, you really have to be starting to talk about some of this nitty-gritty stuff because it really does start to make that difference. So next up, let's take a look at the Texas State Cup, the Armadillo Division. I love this. This is the final qualifier. And I want you to take a look at how these artifacts are going into those original goals and where they end up landing and taking a look at the consistency of those things landing in and some things that your teams might want to try. So we've been talking about this all season, and of course it kind of comes without saying, firing a little bit slower, making sure that you launch things in at a specific point so that artifacts aren't coming out is quite important. Particularly later on in this match, we start seeing that quite a few of these artifacts do end up not making their way into the goal, particularly because of some of these large arc patterns and where the artifacts are actually launched themselves in. And this comes to one of those things I was talking about with some quick wins that your team could do. Now, it is worth doing some testing. And if you are aware of this testing, let us know in the comments down below so more people can benefit from that knowledge. The question of whether you should increase or decrease grip on that artifact for that backspin point. And it seems to me like what would make more sense is to have a frictionless surface on that back so that you're transferring more power into that ball and having less backspin on that artifact, on that wiffle ball as it comes in. Because as we've been seeing for most of the season, when artifacts come to that goal with a really intense backspin, they're more likely to fire out. So getting yourself a really thin sort of tape, something like an HDPE or a Teflon tape, something along those lines. Or I think it was like UWHM something, or maybe that was a string, I can't remember. But there are some specific tape profiles that are frictionless that might be worthwhile, that are quite thin, not going to change the profile too much of your shooter, or realistically at all, because we're talking about, fractions of a millimeter here in thickness. So it shouldn't change your compression much, but it might have a viable shift. I've seen some teams adding grip tape, and it seems to make their shooters perform worse. I have heard of a good chunk of teams adding in some sort of frictionless tape that's quite thin and that is improving some of their performance. So it might be something worthwhile for your team to take a look at just as a quick little shot. I want to give a shout out here to this team as well. Unfortunately, I don't actually know what team number there is because there's no description in here. But I do like and there's no panels on the side of the robot. So if you know this team, please let me know. I quite like their intake design, though, in that it has a moving arm to be able to get itself up and down. I think this is something that teams are going to have to consider as we get closer into far more aggressive defense being played, because this is a concern that I have from some of these robots, is the resilience of them to be able to come in. Something else as you get towards the world stage is that I know that the world stage is changing the gate mechanism as well. I believe they're increasing the thickness of the steel and also swapping out that large gate mechanism that is a large hunk of milled plastic to instead switch it out to something that's made out of steel. So that's going to change how these gate mechanisms are interacting. It might make it more likely for that gate to stay open. But I also think that teams are doing a lot of practice on these designs without the same system being set up. So that might be a bit of a catch-22 when it comes to the World Championship stage, whether it's improvement or it's a de-improvement. I'm not really quite sure at this point what that's going to be. But being able to make your robot more resilient to impacts is going to be quite important. I think this team has done a good job. Next up, let's take a look at a couple impressive autonomouses here. This is team 33700, and they've got a 21 artifact autonomous. And it's very impressive to be able to see that you have some of that high throughput in here. And I think you're really going to see, particularly in that front system, the necessity to always be opening up that gate every single time, because it allows your partner to still be able to get artifacts loading themselves back up in the back end. And then near the end of that autonomous, keeping that gate open so that you can make sure you still have 9 artifacts in there at the end. Now, this is clearly set up for a single autonomous if the partner does not have autonomous there, because they go to pick up that last 3 spike marker. So you might want to set up some of these autonomouses that you play well with your partners. In any case, super impressive work out of this team. We've got another 21 artifacts here out of Xbots, which is 19448. And let's take a look at theirs. And theirs has a really unique intake design. I quite like this. We've seen a lot of robots having a vertical inline intake, whereas this is more of a horizontal on a different axis. So let's take a look at how they have theirs set up. So they're actually able to pick up all 3 horizontally to be able to fire them in. And then it looks like they've got some sort of spin dexter design, quite a quick high throughput to be able to get that through as well. Is quite cool, quite impressive to see. And it's always fun to see different robot designs. They also have quite well-tuned PIDF for their pathing. We can see just how well this thing's able to stop on a dime. It's not overshooting on its paths. At some points, it is collecting too many artifacts. That might be something for them to watch out on. But they are playing nice, and they are making sure that they're getting those leave points as well at the end. So really impressive auto-pathing. I think some teams have a lot of things to learn about for how they could do some auto-pathing like this on their own robots. And then the last thing I want to talk about here is some of that really cool creative design. This is team 22331. They've just got a really unique indexer as well as a way of intaking. So their intake is actually set up on a linear slide on a linkage. So we can see these green compliant wheels here. This whole subsystem actually moves out and in to be able to pick up artifacts and then also launch it into the flywheel. So their spin dexter is able to rotate, it picks up, does their intake, and then the whole system moves back to be able to launch it up into that flywheel. Super cool, really creative. I think it's a very creative way of doing some of that, getting some of that more compact design. And it's also cool to see some linear rails. It looks like that is just standard aluminum extrusion that the subsystem is just sliding on, be it probably PLA or PETG for these kind of little dotted points here. And then they uploaded another video as well where you can actually see this thing firing out as well. So it's you see it do it intakes, and then the subsystem moves back, and then it's able to actually launch them up into that flywheel at quite a high output as well. Super slick. Doesn't look like it from their original video, but it is an awesome design. I love seeing some creative engineering like this. And I want to make sure I highlight that because it's just, it's fantastic, and they should be super proud of that work they have done. If you haven't yet seen it, in order to get flywheel throughputs that have things like this, I just released over an hour-long tutorial on how you can tune your own custom PIDF controllers for flywheels. I walk through everything from control theory and how you can actually set that up with KP, KV, KS, get your flywheel moving from about 1.2 seconds on standard stock down to about 0.2 seconds with basically no overshoot. It's worthwhile to take a look at if you want to understand the more ins and outs of flywheel control theory as well. If you have some matches or interesting designs you think that the team or other teams would benefit from, consider submitting it in that video down below. And as always, best of luck out there this decode season.